All right, folks, welcome back to Mike and Maurice's Mind Escape. We have episode number 175 today. We're going to be doing our Supervolcanoes Part 2 episode. Part 1 was a while ago. I think we did it, 4 or 5 months ago. We got kind of sidetracked with guests and other stuff, but I did want to come back to it because there was a lot more information and there's a lot. We didn't get to any really supervolcanoes other than the Yellowstone, Caldera, and I think Lake Toba is what we focused on the first time. So I thought we would kind of come back around and go through some of it. So before we do that, head on over to our Patreon at patreon.com/mindescapepodcast. For just $2 a month, you'll get exclusive guest episodes and segments. There's some newer ones that I put up there recently, and we have some guests coming up that I'm going to try and get some more up there. We have Matthew Johnson on tomorrow. He's a psychedelic researcher at Johns Hopkins University. So that'll be tomorrow at 11:30 a.m. Eastern Time. So check us out live. And so we're gonna do some more of these Patreon episodes. Also, we're working on doing another secret episode here coming up in the next couple days. And lots of good stuff with that. So also check out our Discord if you haven't already. And if you're wondering, when we're going to do episodes or when our guests are on, you can now go to our Discord. So as soon as I know something, I post it up there. So check that out. And while you're at it, why don't you head on over to indrasweb.org. It is live. We have a decent amount of people on there. I'm going to start probably promoting it more coming up here in the next couple of weeks. So there'll probably be a lot more people on there coming up. So get on there now. If you want to be like an admin or create a group or something, just send me an email and we'll get you set up. Head on over to indrasweb.org. This is a social media platform that we created to connect open minds, all the topics we discuss. Also, we're working on getting that in the App Store as well. So go check that out. What's going on, Maurice?
Not much. What's going on, bro? We gotta give us a nice congratulations for hitting that 3K sub mark.
Oh yeah. Thank you
little
to all
by
our
little.
Yeah, thanks to all our listeners out there and viewers. Also, we're looking to get some of our numbers up on the Apple podcast. So if you listen to us on Apple Podcast, please leave us a nice review if you enjoy the show. We really, really appreciate that. And also, this episode is going to be very image heavy. So if you're not subscribed to our YouTube channel, please check out our YouTube channel. You can just go to mindescapepodcast.com and all the links are up there. Pretty much that's it. But we appreciate everybody listening. And it's been a few years, but it seems to be growing pretty steadily now. We appreciate everybody.
Absolutely.
So do you even remember the first part of the Supervolcano episode?
Yeah, because I think we were talking about it because there was a bunch of news coming out about Yellowstone and the supervolcano under there, and then
that was at the beginning of this whole shutdown thing. There's a lot of volcanic activity, and there, I think Yellowstone. We talked about it on the first part of this series. It has a lot of seismic activity normally, but I think that it didn't stop for like a bunch of days in a row. And of course, people are going to go to Twitter and social media and freak out over it. So,
right. But we were saying, now we are in the window of it erupting, but that window is...
No, it's not. We're not. We're like
5,000 years or something?
No, it's like 500,000 years. It's a long time. We're going to get into that. I actually have that. What I want to do is we're going to go through the first part a little bit. Like I'll go through some of those slides just to kind of rehash things, and then we'll work our way towards the new stuff. So
let's get into it, my man.
All right. Here's just some terminology. A supervolcano is a big volcano that has had an eruption with a volcanic explosivity index of 8 or higher, meaning that the volume of the deposits is 1,000 cubic kilometers or higher. I mean, that's a lot of stuff. The volcanic explosivity index is a relative measure of the explosiveness of a volcanic eruption. Magma. I think most people know what magma is the molten natural material that forms igneous rocks. The layers of the earth, people know that usually, but it's good to go over sometimes.
You never know. You
There's
gotta double
the
check.
there's the inner core and then the outer core and then the lower mantle and the upper mantle and then you have the crust. So I'll be pulling up some diagrams too just to go over. Then you have the subduction zone. So this is a process that occurs when one tectonic plate moves over another plate and the gravity forces it to sink. This process takes place at the convergent boundary of the tectonic plate. The rate of subduction is measured in centimeters per year. The average rate of convergence is roughly, I think it's like 2 to 8 centimeters per year along most of the boundary plates. So, and then, seismic waves. They're waves of energy that travel through the layers of the earth, causing earthquakes, volcanoes, magma movement, and landslides. The Richter Scale. I think a lot of people have heard of the Richter Scale. It was created in 1935 by Charles Richter, and it measures the strength of an earthquake and assigns numerical value based on the magnitude. I think there's a different way that they calculate that now too. I think it's more accurate. I forget the name of it, but Pyroclastic flows. This is a fast-moving current of volcanic matter and hot gas, known as tephra. These flows can range in speed, usually from 100 kilometers to 700 kilometers an hour. The gas temperatures can reach roughly, I think, 1,800 degrees Fahrenheit or like 1,000 degrees Celsius. They're a common and devastating result of explosive eruptions. Once the flow touches the ground, it hurtles downhill toward, it spreads like that. Like most people have seen like volcano movies and stuff. You see the ash kind of shoot down and it's pretty aggressive. And this happens laterally under the gravity. Or under gravity. The Caldera is a volcanic depression that is formed by the collapse of the ground above the magma chamber, which empties during large volcanic eruptions. So, what do you think about all that terminology?
I feel good about it. It's taking me back to the old high school days.
It's good to get some of these, refresher in once in a while. You can't always, everything can't always be, metaphysics and aliens and psychedelics. You got to mix it up here once in a while. So here you see, this is kind of where like a lot of the hotspots are like more, I guess, where you see a lot more activity. That's called the Ring of Fire, even though it's not a full ring. You see it all the way from South America all the way up to Alaska, across to Asia, and then down to Australia. So that's known as the Ring of Fire. And keep going here. Again, some of these are repeats. If you watch part 1, some of this is a little bit of a repeat, but we're going to get to some new stuff here halfway through. Here's the different layers. As I mentioned, the inner core, the outer core, the mantle, the crust. This is also showing you roughly how much, how much is in there, or the extent or the size of these layers. You've got the inner core is 5,100 kilometers, outer core 2,900 kilometers. The crust is obviously the thinnest, and then you get up there towards the top. So, yeah. So this is a histogram of the Earth's crust. At the very top right there, you can see that's a little red Eiffel Tower just for scale. And then you got the highest point there on the left, which would be Mount Everest, the highest point on Earth. And then you go all the way down and you go to the greatest depths, and that's the Mariana Trench. So you can see roughly scale-wise how the highest peak to the lowest depths of the crust. Okay, so this is a picture of the core and how the Earth's magnetic fields interact with the core. So part of the reason we know kind of what's going on is obviously the material and however like it relates to magnetism. So if you see there's diagrams of like the Earth and like the magnetic field around the Earth that all has an effect on our core. And I would look at our Earth kind of as like a giant gyroscope. There's a bunch of like moving parts and different layers and stuff like that. So it's not just obviously a solid ball. There's a bunch of different stuff going on in the interior.
Absolutely.
Maurice really getting it in tonight.
He's always got to say something, folks.
Well, look, we were going to do this last night, and then the software that I used, they had some update, and after I updated it, it wasn't working like it normally should. So I got with them. They were pretty quick about it. They were able to do another update today. So here we are. So these are all the different geological provinces. You have their little key on the left. I'm not going to, again, spend too much time on this because we did go over it. Okay, so this is important, though. Again, so this is how they determined a supervolcano from just a regular volcano, or it's like a stratovolcano. The VEI has to be 8 or higher. The VEI is a relative measure of explosiveness of volcanic eruptions. It was created in 1982 by Charles Newhall of the United States Geological Services and Stephen Self from the University of Hawaii. The VEI includes things like eruption and cloud height, volume of product, qualitative observations. The scale ranges usually from 0, which is like gentle, to 8, which would be megacolossal. And some of the examples of megacolossal eruptions are the Huckleberry Ridge Tuff. I got a map of that I'll pull up here in a little bit. The Yellowstone, Lake Toba, and Taupo. Taupo's in New Zealand. And Lake Toba's in Sumatra. A list of famous volcanoes and their VEI numbers are Kilauea, since it's had a bunch of eruptions. It ranges from like 0 to 4 usually. Vesuvius, 5. Mount Fuji, 5. St. Helens, 5. So if you think the St. Helens is 5, a supervolcano is like probably 40% bigger than that, or
Crazy.
more explosive. Krakatoa, which is a 6, and Krakatoa was a big deal as well. The Valles Caldera, that's a 7. Thera, which is a 7. Some people even think Thera might have been Atlantis. I know National Geographic did a special on it. The timelines don't necessarily match up. I think Thera blew up, I want to say 1600 BC, somewhere about there. But yeah, there's some people think that could be it. And then you've got Taupo, again, 7. Huckleberry Ridge Tuff, 8. Yellowstone, 8. Lake Toba, 8. Taupo, 8. Some critics of the VEI point to the fact that the ash, the lava bombs, and the ignimbrite are lumped in together, and the density is not figured into that. So it also doesn't take into account the power of the output, which would make it tough to determine the accurate VEI for the prehistoric and unobserved eruptions. So
here's a little trivia for you. What's the biggest eruption that we've had in the past 10,000 years?
What's the what?
The largest volcanic eruption in the last 10,000 years.
Is it the one in Alaska in like 1917?
It's Tambora.
Oh, yeah. We're gonna get to that. That's in there as well.
Beautiful.
All right, moving on. Okay, so there's a couple things going on in this picture. This is the Yellowstone National Park. This is the Yellowstone Caldera. You see, so there's one that happened, the first one that happened would be the first caldera 2.1 billion years ago. That's, I think, the light, I don't even know what color that is, like lavender.
Yeah.
And then the second one, 1.3 million years old. I think that's I'm drawing a blank on the name, but that one was 1.3 million years ago. So that's the second one, and then you've got the third one, which happened roughly 640,000 years ago. And again, not all of the Yellowstone super eruptions have been these explosive eruptions either. They've had lava flows and stuff like that too. So there's one that even erupted 174,000 years ago. That West Thumb Caldera erupted. So yeah, there's some different stuff going on.
And if people are wondering those names, you can go back to our other episode. We go into more in depth about the Yellowstone eruptions.
Yeah. And that Henry's Fork Caldera, that's the one that was on the left. Here, let me go back. That was the one that was the second caldera 1.3 million years ago. And then you've got the bigger Island Park Caldera there in the middle. Okay. So here's just a general diagram of, what they're pretty sure is going on below the surface at the Yellowstone Caldera. At the top, you see the rim boundary faults, and then you see like the geysers up top, and then below the geysers, you get that heat coming off of that magma or that partial melt. And then on each side, the crust is stretching, and you've got earthquakes that happen. So all these kind of things just kind of come together. And there's no imminent super eruption coming like everybody says. I see all these like reaction videos on YouTube and then like people talking about it. It takes like 10-15 minutes to like look this stuff up.
Well, the bottom line is it is coming, but not soon.
Yeah, of course these are all going to happen at some point. You're right, but it's not for like hundreds of thousands of years, number one, or at least they don't work like that. Like some people would like take the dates of these and then average them out and see, when's the next one due to occur, but it doesn't work like that. Anything could happen. If a comet or an asteroid hit, I think that would have obviously a huge impact. That might have set stuff off in the past as well, so I think it really just matters when they pay attention. That's why you have all these like seismic graphs and these scientists monitoring these things. There's a whole reason why that's going on.
Right. And we're also in the works of figuring out a way to go in there and depressurize it.
Well, we talked about that last time, that they're not going to be able to do that. I think JPL said that their best theory would be to maybe shoot hot water into the side of it, or like inject water into it. But even that could have some sort of a consequence as well. So, look, when one of these things happen, there's really no recourse. It's just going to happen. So, moving on here. Okay, so the Yellowstone Caldera. The Yellowstone Caldera is a supervolcano and a volcanic caldera located within Yellowstone National Park. The caldera and a large portion of Yellowstone Park are located in the northwest corner of Wyoming. The main part of the caldera is roughly 35 by 45 miles. Yellowstone sits on 4 overlapping calderas. The first caldera is 2.1 million years old and had the ejecta volume of 600 cubic miles. Second caldera, 1.3 million years old and had an ejecta volume of 76 cubic miles. Third caldera, 640,000 years old, had the ejecta volume of 240 cubic miles. And then the fourth caldera erupted again 174,000 years ago, and that wasn't a large. I think it was just lava flows. So these calderas are, and that's the other thing. I mean, Yellowstone could go off again, but it might just be a lava flow. It's not necessarily guaranteed to be a super eruption. So these calderas are located on the hotspot underneath the Yellowstone Plateau, where light and magma, light and I don't even know what I put there, but magma rise from the mantle. Okay, moving on. Any questions so far, Maurice?
No, sir.
That's right. You better not have any questions. All right, so this area has been active for over the last 18 million years, creating violent eruptions and less violent basaltic flows. So again, they could just be basaltic lava flows and floods. Roughly 12 eruptions in this area helped shape the eastern part of the Snake River Plain, which was once a mountainous region. Yellowstone has had non-explosive lava eruptions and less explosive eruptions since the last super eruption. Let's see here. The tectonic and volcanic activity in the area or the region causes between 1 to 2,000 measurable earthquakes a year. So that's a lot. I mean, there's a lot of activity there. I mean, a lot of them are probably so minute, they're probably don't even really register to most people. But I know there was one at the beginning of last year that had people freaking out. It was like in Utah or something, or Idaho maybe. I forget. It was like a 6 or a 7 maybe. I'd have to go back and look. But in December of 2008, over a couple months, there was over 500 earthquakes, with the largest recording of a 3.9 on the Richter scale. There was also volcanic swarms in 2010, 2014, and 2018. Some studies and analysis show that the hydrothermal explosions can occur independently from volcanic eruptions and may be even more imminent of an imminent hazard. In the last 14,000 years, 20 lake craters have been formed, creating lakes, bays, and ponds. In 2016, the USGS announced that they were going to map these subterranean hydrothermal systems. Again, the USGS is just the United States Geological Survey. Or Services. I forget. Look that up. Is it Services or Survey?
Hold on a second here.
Yeah, I don't know what you're looking at right now, but you better be looking at that. Just type in usgs.gov. Recent supervolcano hypothesis and news. So this was somewhat recent last year when we went over this the first time. The hotspot under Yellowstone has migrated over time from southeast Oregon through Idaho to the northwest corner of Wyoming. But it's not necessarily migrating in the sense like the crust is moving and everything's kind of shifting. I think when we had Chris Cottrell on, he was talking about that. So it's not necessarily that these hotspots are moving, it's that the crust is moving over it. Thomas R. Knott is a geochemist at the University of Leicester, and his team used paleomagnetic analysis because the iron that was ejected would have been liquid and would have settled and cooled towards the magnetic north. Knott said since each Yellowstone super eruption would have been slightly different in chemical profiles because different sections of the continent are being melted. I mean, that makes sense. You think that whatever is in the earth being melted, there's obviously going to be different compositions.
It is U.S. Geological Survey.
Yeah, survey. That's right. Good one. Thank you, young Jamester.
Yeah, I had to really search on this website. It didn't just pop it up. It doesn't say anything. It just says USGS. Had to go into the about and email them to find the name for it.
It was, and they have they've got a lot of good information on there too. So if you're interested, obviously their website, wiki, all there's good stuff on all of it. Let's see here. Where was I? Okay, it was originally thought that there were a bunch of smaller eruptions in southern Idaho. However, Knott says evidence suggests that the last two super eruptions, including the top 5 eruptions of all time at Gray's Landing. McMullen Creek was a super eruption, was dated to 8.99 million years ago, and it covered over, I think, 4,600 square miles stretch of where now southern Idaho would be, and it registered an 8.6 on the VEI index. And then the Gray's Landing one, which might have been the largest of all time, it was a super eruption which was dated to 8.72 million years ago, and it covered 8,900 square miles in southern Idaho and northern Nevada, and it would have registered an 8.8 on the VEI and is rated as a top 5 eruption of all time. The VEI only goes up to 8.9.
Damn.
So, yeah. I mean, look, if you look at North America, a lot of North America was probably shaped by some of these early supervolcanoes. So there was probably a lot more mountains before that. And then you have these supervolcanoes coming in, and like they mentioned, the East Snake River Plain was formed from these super eruptions.
Yeah, that's I think we're gonna be hiking out there soon, either Yellowstone or the Tetons.
Yeah.
And that Snake River, that picture from Ansel Adams is like one of the most iconic.
Yeah.
You know what picture I'm talking about?
Yeah, I do.
I love that area, but you can tell that those crags were created not slowly because they're very jagged and it's intense.
Yeah. And actually, too, if you're interested, check out Maurice's adventures, because he goes to, you're in Washington, you're in the Rockies, you're all over the place. So
yeah, it'd be really cool to go out there like to Yellowstone and then have
you
some
guys
of this
should
knowledge.
go to the Gorge and go hiking around there.
That's in Washington, right?
Yeah.
Yeah.
Oh,
you
went to Oregon. That's
right. Well, the problem is the guy I go with has been to. I try and do stuff that he hasn't been to yet. So
yeah.
Colorado. We've been to Colorado the last 2 years. You could hike in Colorado the rest of your life and still not see everything. I love Colorado for backpacking.
I still
highly recommend it.
I still think you should go back to whatchamacallit. You should go back to I don't even forget. Oh, Glacier National Park.
I know. That's his favorite place. My cousin, he said it's the best park he's ever been to. So I'm sure I'll be able to get him to go back.
Yeah.
At some point in his life, he keeps claiming that this is the last trip. This is the last trip, but
right.
He's gonna get a band. I'm gonna wrap up his knee, and we're gonna hit the trail again. His knees are just getting real old, as he is.
All right. Some geologists agree with the findings and suggest that we still don't know the cause of the magnetic flare-ups, especially over hotspots. The USGS geologist Michael Pullen says it would make sense that Yellowstone hotspot would weaken as it migrates inward towards the thicker part of the crust or the continent. Still, other scientists suggest that this only makes sense if you only look at the largest eruptions throughout the supercolossal eruption history that are very, there's other ones that are very dangerous as well. So this is what I was kind of talking about, migrating the 16.1. It migrates from the corner of Oregon all the way up through Idaho, and then you get to the top left corner of Wyoming. But again, it's the crust moving over, and then the magma comes out, and super eruptions probably occur when there's thinner spots on the crust too. So, but yeah, it's a good way you can see how that kind of evolves over time, and it does look like that bottom there in Idaho. These other ones, 10.7, 10.7, those were some big ones.
And that's the Snake River.
No, I think Snake River 6.4. Oh, actually, that might have been.
No, I'm saying that river that's flowing through there, that's the Snake River.
Oh, yeah, I don't know. Look it up. Look up what river runs through southern Idaho. You're probably right.
I never even thought. I just watched a documentary about Idaho. I never thought it was even cool, and then I started watching this thing. People.
Oh, it's sick out there.
It's unbelievable.
Yeah.
It's like a state you never even think about. Everybody thinks, well, Wyoming and obviously Montana and Colorado, Utah, but no one ever thinks of good old Idaho. You just think of Idaho potatoes.
What was I going to say? Oh, yeah, I mean, beautiful, if you want to see some beautiful landscapes, Idaho, Utah,
Well, Utah is more southern.
I mean, it depends on what you're looking at, but in terms of like those kinds of similar landscapes where it's like dry, arid with a lot of rock formations. Those are
I
places.
but I think Idaho has all kinds of different stuff.
Well, you can see right there. Look at all the topography on the on the top part of the river there. I mean, that's all high elevation.
I can't. This is really turning into a pain. There she blows. Yes, the Snake River. That thing's gigantic.
Yeah, I wanted. Where did I go? I've been to. I don't know. I need to get out west more. I've only been to Vegas twice. And I was supposed to go to California for a work trip, and I ended up getting sick a while back. So.
Yeah, I've never been to California. I've been to Oregon. The Oregon beaches I heard are similar to the Northern California.
Didn't you go to the Oregon beaches when you guys were done with your one hike?
Absolutely, and Cannon Beach is one of my top 5 cities they visit. So maybe we'll do a little podcast on our top 5 cities in America, because there's some cool stuff out there. Yeah. I haven't really ventured too far out of the United States. I've been to Canada.
Yeah.
But I haven't really been to any other country. But I have traveled a lot within the United States, and it's pretty, and there's a lot of stuff to see. So.
Yeah, I mean, most of mine traveling is all Midwest and then East Coast and Southern, Florida and Georgia, all down there. So, okay, let's see here. Okay, so this is what most people want to know. This is,
this is the meat and potatoes.
Yeah, is Yellowstone due for an eruption? And I would say, based on everything I looked at, no. But again, this isn't something that you can just, they would see a buildup and a lot of, changes in seismic activity, and the caldera is shifting and then the landscape shifting. I don't think that, unless they see that, nothing's imminent, obviously. So, but according to the USGS, it is not due for super eruption, nor is one imminent. Again, they kind of have that same take on it. Volcanoes are unpredictable, and the most volcanic systems that have had super eruptions do not have them again. So once one's already had an eruption, it's most likely not going to have another one. Yellowstone is unique in that it's had 3. And then again, that 4th one was kind of just that basaltic lava flow. The first was roughly 2.08 million years ago. Again, this is just a repeat of what we were talking about earlier. Second one, I think that's the one that was at Henry's Fork caldera. That was 1.3 million years ago. And then you have the one at 631,000 years ago. The average time between super eruptions. Okay, so this is where we're at. So if you were to take the super eruptions and kind of look at the distance of time between each of them, there's, on average, I think it's 725 years. So based on that trajectory, we're about 100,000 years away from, if that were to happen like that, which the scientists don't believe that that's the case. But if it were, we're 100,000 years away.
Well, again, not to play devil's advocate, but all they can do is just estimate these things.
Right.
They don't really know for sure.
And again, I mean, different things could happen, geological events, and then you also have potential for, comets and asteroids and that kind of a thing too. So there's no real, nothing's set in stone.
Well, they've been calling for a massive earthquake to come and destroy California for a long time now.
Well, that was always been a myth, right? Since we were in school.
The big one.
So the Rhiolite magma chamber under Yellowstone is only 5 to 15% molten. It would need to be 50% melt for an eruption on so like the melt is like what in there is actually not solid. Right. And for that to occur, it would need to be at least 50%, and the average is 10%. So on average, most of these places are at 10%. Yellowstone has erupted both basalt and rhyolite in the past. Rhyolite is an extrusive igneous rock that has a high silica content, and basalt is an extrusive igneous rock rich in magnesium and iron and is formed from rapid cooling. The rhyolite partial melt is located in the upper crust and it's under the Yellowstone caldera, and it produces the hydrothermal fluids. Below that is the basaltic partial melt, and that's in the lower crust that is 4 to 5 times larger than the rhyolite melt chamber. It also provides heat for the shallower rhyolite melt. It also stretches from under the part of Yellowstone caldera to the edge of the east Snake River Plain. So again, these supervolcanoes is what helped create the East Snake River Plain. Okay, why are there so many earthquakes at Yellowstone? Most of the earthquakes at Yellowstone are a result of breaking and rocks breaking caused by crustal stresses called brittle failure events. No one has ever observed or identified a long period event, which is also what's connected to the movement of magma. Even if there was a long period event, that does not necessarily mean there will be an eruption. The ground shaking or tremors are observed near the geothermal areas when the water boils in a geyser. Okay, so we're getting towards the end of Yellowstone here, and we're going to start getting towards some other stuff. Let's just wrap up Yellowstone. So Yellowstone is roughly 3,400 square miles of wilderness. It contains hot springs and geysers. Geologist Bob Christensen has done a lot of research on the topic of supervolcanoes and geology. There is tons of heat below Yellowstone, 30 times more than anywhere in the Rockies. I mean, that's kind of crazy. Yeah. On August 17th, 1959, a massive landslide at Hebgen Lake killed 28 campers and 19 were never found. The deadliest earthquake since 1933.
So it killed 20 or it killed
28? It killed 28, but they couldn't find 19 of the people, which usually...
Well, they're presumably dead.
Yes. Yellowstone has an average of 25 earthquakes a week, second to only California. Yellowstone super eruption could produce 250 cubic miles of ash. That would be enough to bury Texas under 5 feet of ash. That's kind of crazy. Let's see here. The Yellowstone caldera is so large, the whole thing can't even be seen from the air. I mean, think about that. So, in the 1970s, geologist Bob Smith surveyed the Yellowstone landscape. He noticed a change at the south end of the caldera. It was 18 inches off the survey from 1923. So the caldera had risen over 2 feet in 1995, and 2000 it went back down.
So that's probably why people were getting intense about it.
Yeah, I mean that guy was actually observing a change in the landscape. That's a little bit different than what's, people just every time there's an earthquake, because an earthquake isn't necessarily going to induce that. So
right. Plus half those 25 or most of those 25 are so small you can't even notice them.
Right. There's evidence that Yellowstone Lake was inhabited seasonally by Native Americans, the Clovis people, starting around 11,000 years ago. The rising and receding lakeshore revealed arrowheads and archaeological sites. Kind of just an interesting little fact there.
That's awesome. I'd like to go there and maybe try and find one of those bad boys.
Yeah. Okay, so here you have the East Snake River Plain. You can kind of see how it's been blown out there in the middle. Keep this moving. Okay, so this is a good example of like what if Yellowstone did erupt. So the type of explosive magma that is under Yellowstone caldera is comprised of silica gas, which makes it a supervolcano. The chamber must contain at least 50% melt for an eruption to occur. The average stable level of melt is 10%. If it were to erupt, okay, so this is what's going to happen. Swarms of earthquake would plague the area. A long continuous vibration, harmonic tremor, and it is the last warning. So you're going to hear probably some like loud, weird noises, okay? The eruption would be 50 times the largest atom bomb. Man, that's very large.
Oh my God.
Yeah. A 60-mile radius would be very hazardous. There would be a possible destruction up to 200 miles away. Pyroclastic flows reaching 1,500 degrees would flatten and scorch the surrounding area. At night, pyroclastic flows would be incandescent. So if you could actually be alive to see that, that might be beautiful. But
Oh yeah, the photos would be unbelievable.
it can engulf Jackson Hole. Most people and animals would suffocate in the flows. The mother of all ash clouds and the deadliest debris would shoot 15 miles into the atmosphere. The skies would turn deadly and dark. Wet ash would clog filters and collapse roofs. Swirling ash might induce intense lightning. Salt Lake City and Denver would get up to 3 feet of ash and it would cause mud flows and damage. People will panic. Lawlessness would ensue. 500,000 people could die. Inhaling volcanic ash is basically glass and shards, and anyone who does not or who does survive could potentially get a severe lung or have severe lung issues. Nobody within 1,000 miles would be safe and could develop Marie's disease. Gases might stay in the air, affecting air quality and the atmosphere. So Marie's disease, I think they found it in some animals near eruptions. It's like when your bones get like denser, thicker, and then like overtakes your body or something along those lines. In 1816 and 1817, there was a famine from cold weather caused by a volcano eruption. In 1815, this is the one you were talking about, in Tambora near Java. So 10,000 miles away, people were affected. Sulfur dioxide, sulfuric acid aerosol spread by the stratospheric winds. Tambora killed roughly 71,000 people. I mean, that's a lot.
Yeah, for back then.
It was 1800s. It's not that far back.
No, I'm saying, well, the amount of people that are around now.
Yeah.
Like if Yellowstone erupt, I was just gonna say we're almost exactly.
I mean, but Java's
more than 1,000
there's
miles
probably
away.
You're right. There's probably obviously a lot more people there, but I mean, you're in Indonesia, so it's there's a lot of islands too, so it would just depend, I think. But Yellowstone eruption would cause a drop in temperature roughly 10 degrees Celsius. So I mean, that's a big deal.
Yeah, the whole sun would be blocked out.
Okay, so this is the volcanic ash fall from Yellowstone. So there you can see what's highlighted. At the top left, you see that's the ash from Mount St. Helens, just that like yellow, little colored in area. Bottom left, you have Long Valley Caldera in California, and you can see that one's got a decent size, that dotted line on the interior. And then you've got the Bishop ash bed. And then the big one, obviously, is the triangular looking one, the Yellowstone Plateau. I mean, that's pretty sizable.
Oh, yeah.
Even the Huckleberry Ridge one looks pretty devastating.
It's just to the edge of Illinois.
Yeah, that's crazy.
So you'd be, unless the winds were blowing.
Yeah, again, there's Marie's disease and lung issues. I mean, all right, so we'll talk a little bit about Lake Toba here. There you see it on the left. There's a better picture where you can see it, the lake, and then the little island thing in the middle. I think it's called Samosir. It's the resurgent dome. So that's when that grows. That's what erupts, is that little island. Okay. Lake Toba is a natural lake that formed in the caldera of a supervolcano. The surface elevation is just under 3,000 feet. It is 62 miles long and 19 miles wide. It is the largest lake in Indonesia and the largest volcanic lake in the world. Lake Toba registered an 8 on the VEI index. It is also the largest explosive eruption in the last 25 million years. It erupted 74,000 years ago, killing most humans at the time. And that's not an exaggeration. The theory goes is that there's genetic evidence that the human evolution went through a bottleneck, and a few to 10,000 breeding humans survived based on the migration evidence. So just think about that. 74,000 years ago, there was only probably 5 to 10,000 people left on Earth after this eruption. I mean, that's just crazy. And we know Homo sapiens sapiens we've been us for about 200,000 years. So we were us, for at least 125,000 years at the time.
Uh-huh.
So, I mean, that's just crazy to think about. Let's see here. Okay, so Lake Toba led to a volcanic winter worldwide, causing a drop in temperature between 5 and 10 degrees Fahrenheit and 27 degrees Fahrenheit in the higher altitudes. That's pretty crazy. So 5 to 10 is a big difference from what we were just talking about.
Yeah, that's Fahrenheit. You were saying 10 Celsius.
Well, it's this, I mean, even, it's relative depending on, obviously there's the difference in the system, but additional evidence at Lake Malawi in East Africa show large ash deposits. And Lake Toba was the last in 4 caldera forming eruptions. Some parts of the caldera show magma chamber refilling, which raised Samosir Island and the Uluan Peninsula above the surface of the lake. Lake Toba is near the Great Sumatran Fault and the Sumatran Fracture Zone. Large earthquakes have happened near there. I think 1892, 1916, 1920, and 1987. There is a closer picture. There's Samosir Island in the middle of the lake. Here's a little bit of a different view. There's an aerial shot. It's beautiful, though.
Oh, yeah. All that stuff is top-notch photography.
Look at that shot.
That's bomb.
Okay. So here's where we're going to get to some newer stuff now. Okay, so this is pre-eruption, right before the eruption. In 1991, the eruption of Mount Pinatubo in the Philippines, which was a stratovolcano, and this volcano cooled global temperatures from, for about 2 to 3 years. So that's actually kind of a long time, and we're talking 1991. So look at that. This one's probably actually one of the more well-documented volcanoes. So this one, I think, is a 6 on the VEI index. So it's not quite a supervolcano in the sense of being an 8 or higher, but 6, and then having that massive impact and being a stratovolcano definitely will do some damage.
That's, yeah.
Look at that. That does look like a bomb. It is very scary.
Plus the houses, they look all modern, so it's like
look at that picture.
They almost like a horror, scary photo.
And then this is, I think, a couple weeks after the eruption. You just see the layers and layers of ash up there.
I wonder how far away that is from that shot.
Yeah, they're obviously in a helicopter or something. Here's what happened. This was.
'Cause I'd be flying real quick.
This is from the Pyroclastic Flows. And then this is I think this is the ash range of the eruption. So you can see it's kind of dispersing all over Asia there.
It's just a nice blanket.
Okay, so here's part of the issue when one of these huge eruptions occurs would be a lot of stuff getting in, a lot of stuff's aerosolized and gets in the air, and then it blocks out the sun. And there you can see there on the radar, or the graph there. Let me pull up a different one. Here, this one, you can get a better. And yeah, so that has an effect, obviously, when the light can't get through, it affects everything.
Absolutely.
Here you see the rise in sulfur dioxide. You have 2 spikes here, but obviously the largest spike is the Pinatubo. And okay, so here's the atmospheric transmission. So you get so this is how much radiation was getting through, and you see El Chichon, I think that's how you pronounce it. That has a massive drop, or Chichon. And then you've got Pinatubo that has a pretty big drop as well. So when these eruptions occur, there's not going to be much radiation or light, any of that stuff kind of getting through. So this is a graph showing how over time, that started to change there. So you see it starting to get back to normal. So after the eruption, you see the spike, and then it slowly starts to dissipate and goes back to normal. Okay, so that's an aerial shot of Pinatubo. I'm sure some people will comment what that means.
El Chichon is in Mexico.
Is it Chichon?
Chichon. Oh, you're talking to mystery literate here.
Yeah. All right. So now we're moving on. Now these are all like the hot spots. As you can see, all those little red dots. You see a lot near the Ring of Fire. You've got the one, I think, what is that, 32? It's Yellowstone. And then you get up towards Alaska. And then down, there's a lot in the ocean. Obviously, a lot of the South Pacific Island areas. Down and around the rim of South America. And then there's a lot in the Atlantic and the lower Atlantic in between Africa and South America. And then you have a lot through like the Rift Valley area of Africa.
Yeah, it's awesome to look at. You can blatantly see why the continent ripped apart.
Right.
Old Pangea.
Yep. Okay, so here we get to some of the other more famous eruptions of all time. So I did this in chronological order from the oldest, most significant ones to the most recent significant ones. So this is Wawa Springs. It's in Utah, and it is this eruption 30,600,000 years ago, and it's part of the Indian Peak Caliente Caldera complex, which is what the volcanic zone is. Let's see here. It is the largest of the Indian Peak Caldera complex eruptions. It was preserved as the Wawa Springs Tuff, and it includes pyroclastic flows more than 13,000 feet thick or 4,000 meters. That's crazy. And the ejecta volume was 5,000 to 5,900 cubic meters. So I think, what was the one that we were talking, the Yellowstone one was 600 cubic meters.
How do they even measure this stuff? They just find the rock and...
What do you mean?
Like how do they? 30 million years ago.
No. The geologists, there's geological records through like the different layers. They find layers of ash. They can tell how far. How much of it's preserved, how thick the layers are, and then how far distance, and then they just kind of it's just building models from there.
Right.
So, La Garita Caldera in Colorado, 27,800,000 years ago, and it's part of the San Juan volcanic field or volcanic zone. The Fish Cannon eruption was one of the largest known explosive eruptions with an ejecta volume of 5,000 cubic kilometers. That's crazy. That's crazy. There you can see, I think that's Fish Cannon or Canyon right there. That's a kind of a cool pic. That looks like a cool area.
I want to go visit this. Never even heard of it. That's what I was saying. Colorado's got so much to offer.
We're going to send you out in the field, start getting some soil samples.
I have heard of the San Juan area. We were going to hike around there. But yeah, it's like, that's in Colorado? What the hell?
Well, I'm sure there's a ton of cool stuff in Colorado.
No, I know. I'm just saying that doesn't look like a normal... That looks more of like Utah-y to me, but they're all connected, so not surprised.
Let's see here. The Heiss volcanic field, it's in Idaho. It's part of the Yellowstone Hotspot volcanic zone. It's where you get the blacktail tuff, and it's 6 million years old. I mean, that's, again, we started from 30 million, now we're at 6 million. That had an ejecta volume of 1,500 cubic kilometers. Let's see here.
That's nothing.
Oh, yeah. What do you mean? Again, if what I was telling you was going to happen at Yellowstone, that was 600 cubic kilometers.
Okay.
So.
Yeah, that is big then.
I mean, when you think of this kind of stuff, like, I don't know. I think about that, like, when you look at, like, the U.S., you know, like, when you look at, like, there's fires out west, or there's tornadoes in the Midwest, or there's, you know, hurricanes in the southern, you know. Do you ever think about that kind of stuff? Like, where would be the best place to live from, like, natural catastrophe type stuff?
I mean, actually, where we are is pretty damn safe.
Yeah. But I wonder if water levels rose, if that would have, obviously, an impact on
Yeah, I don't
the
know.
Great Lake regions.
It might, but I think it has more to do with the oceans.
No, but what I'm saying is the St. Lawrence Seaway, like, all that water, comes from, you know, there's channels there.
Right.
So it would definitely if there was, like, a large influx, it would force its way over that. No.
That's true.
Questions asked.
Oh, I'll ask.
I don't know. I just, like I said, I think of that stuff sometimes. It's not necessarily.
Probably like Kansas or something, but you're still in harm's way from the volcanoes.
That's what I'm saying. The supervolcano.
I think the water is the more of the threat, though, the more realistic threat.
Yeah. Yeah.
In our time, at least, you know.
Yeah. Yeah. I mean, I just.
But that's the price you pay. You go and live in California or Florida, and you got to deal with hurricanes. And
yeah,
I don't
it's
think
beautiful
Florida
most of the time, and once in a while there's
hellish.
Yeah.
I don't think Florida gets that many earthquakes, though, does it?
No, they don't get earthquakes. They get hurricanes.
Right.
What was I gonna say? Yeah, but the thing about, you know, some of those hurricanes, you know, like, some of them are pretty brutal too. You know, I know.
Oh, yeah.
For the most part, it's usually fine, but you know, it can get out of hand.
That's why, like, the homeowners insurance is astronomical down there.
Yeah.
I've been looking.
He's already looking to retire, folks. Mr. Maurice.
I was literally looking at it. I was wondering why the houses were so cheap. It's on a golf course. It's like an older folks community down in Florida.
Yeah.
Nice homes, though.
Let's see here. Okay. Now we get to Cerro Guacha, I believe is how you pronounce it, in Sur Lopez, Bolivia. It's part of the Altiplano Puna Volcanic Complex, Volcanic Zone. There's two smaller eruptions that are identified there. I think it's 5,700,000 years ago. So, I mean, that's a long time. And had the ejecta volume of 1,300 cubic kilometers. That's just crazy. There's a satellite shot of it from over top the Earth. That's pretty.
Get myself a helicopter and just. Really
there we go. Then we're gonna really send you out into the field, get some stuff done. For the South America volcanic areas, obviously we showed you the graphs at the beginning with, like, the hotspots and the Ring of Fire and stuff. But at the top left, you have the northern volcanic zone, which Ecuador up there. And then you get down further and you start getting into, like, Chile, and then you get down to Argentina. So yeah, you have the central zone, volcanic zone, and then the southern volcanic zone. The Juan Fernandez Ridge there down below. Let's see here. Here's another Heis, I don't even know how you pronounce that. Volcanic field in Idaho is the Yellowstone hotspot volcanic zone. So again, Yellowstone has produced a lot of these eruptions, or there's a lot of calderas in that area. This produced the Kilgore Tuff 4,500,000 years ago, with an ejecta volume of 1,800 cubic kilometers. In Chile, you have La Picana, which is in the Andes Central Volcanic Zone. It is responsible for the Antana ignimbrite. And you've got this was 4 million years ago, with an ejecta volume. Wow, it's kind of a lot, though, is 2,500 cubic kilometers. So, again, I mean, the first ones I brought up, though, were like 5,000 cubic kilometers. So, again, these would be the areas. So, wait, where were we? So, that one was in Chile, so down there at the bottom. So, you're talking in between the central volcanic zone and the southern volcanic zone down there. Let's see here. Here you have Cerro Galan, I think how you pronounce it. Catamarca, I think that's how you pronounce it, in Argentina. It's part of the Andes Central Volcanic Zone. It consisted of 3 distinct eruptions separated by 30 to 40,000 years, and it is 2,500,000 years ago, with an ejecta volume of 1,050 cubic kilometers. Okay, here's again that same one. I just want to keep showing this because this is where all the activity is in South America. And here you have an overhead shot of it, an aerial shot. And you can kind of see there in the middle how everything kind of dispersed out. Okay, you get to the Huckleberry Ridge Eruption in Idaho. So this is part of the Yellowstone hotspot, again, the Yellowstone Volcanic Zone. The Huckleberry Ridge Tuff consisted of 3 distinct eruptions that were separated by years to decades. This one was the one that we talked about earlier, which was 2,100,000 years ago. And this one had an ejecta volume of 2,450 to 2,500 cubic kilometers. Again, this is half of the first 2 that I talked about, but yes, this is a lot. The Manga Kino caldera, this is part of the North Island in New Zealand. It's part of the Taupo volcanic zone. It was known as the Kidnappers Eruption. And this was 1,080,000 years ago, and it had an ejecta volume of 1,200 cubic kilometers. This here I pointed out, as you can see, that little arrow is pointing to the Manga Kino caldera. You can see it there. It's kind of like a little spot there right next to the arrow. And moving on, now we get to the Bishop Tuff. This is in California. It's part of the Long Valley caldera. A single eruption completed within 6 days. The volume and dense rock equivalent. So this one was 760,000 years ago. This one had an ejecta volume of 600 cubic kilometers. So again, that kind of seems small compared to the ones, some of the big boys we were just talking about. And here is a picture of that. It's beautiful.
Mm-hmm.
And here you have an overhead shot with a little diagram there, so you can see the caldera boundaries. And then you see the resurgent dome there in the middle. Again, the resurgent dome is the point where it starts to... that's what's growing before the volcano erupts. So when I showed you Lake Toba, that resurgent dome, after Lake Toba erupted, there was probably no resurgent dome, and it just looked like a bare lake. And then the resurgent dome comes up and it turns into Samosir Island. So that's kind of what's going on there, but on land. Look at that. That's a beautiful, nice, crisp shot.
Breathtaking.
Yeah.
I mean, these volcanoes are responsible for madness, but they're also responsible for some unbelievable scenery.
Yeah. Yeah, absolutely.
Mountains, lakes, rivers, all that stuff.
I mean, they might even be responsible for creating us, too, in the sense that one of the theories, I think, for abiogenesis is that underwater, those hydrothermal vents that have you ever seen those, like underwater?
Yeah, absolutely.
They think that some sort of, organisms or organic compounds formed with something going on there, some process that formed the earliest organisms.
Well, they just found a ton more species of stuff down in the ocean coming out of something like that.
Really?
Did you see that article?
Oh, was it the cave that they found with all like the albino, like insects and reptiles and stuff? I saw.
No, these were single cell.
No, yeah, I didn't see it, but I saw there was one where there was like a secluded cave system or something where this thing didn't have access to the outside world for like millions of years, and all the insects and animals were all albino that lived down there.
Weird.
Yeah. So here you have the Long Valley caldera. You can see there, which we've been talking about here. Bottom left, it's circled. The bishop, the ash there in the top right corner, you can kind of see and how it dispersed out. So yeah, and then you have obviously the fault in that area. Okay. Here's another picture. I think Randall Carlson pulled up a couple pictures of volcanic activity and when we had him on too. I don't know if this was one of the pictures or similar. I'd have to go back and look. Okay, so the Lava Creek eruption, which was in Idaho, Montana, and Wyoming, was part of the Yellowstone Hotspot Volcanic Zone, and the Lava Creek Tuff consisted of two distinct eruptions separated by years. This is the Yellowstone one that we were talking about that was 640,000 years ago, and this one had an ejecta volume of 1,000 cubic kilometers. There you go. There's a picture of the side of it there. Okay. Now we're getting to the Taupo Nui Atia. That's part of the North Island of New Zealand and part of the Taupo, Taupo, I don't know how you pronounce that, but volcanic zone. Waka Maru Ignimbrite Mount Curl Tefra. Okay.
Jesus.
That's a real mouthful.
Yeah. Well, yeah, you should have had me say that. That's a real comedy.
And that one was 340,000 years ago, and that had an ejecta volume of 2,000 cubic kilometers. Here you can see I circled that little area there, and then we have the arrow pointing to the area where the super eruption occurred. Let me go back one actually. So yeah, that was the whole zone in that area, and then I'm pointing specifically to where the caldera was at. Okay, so this is one we already talked about, but the youngest Toba eruption. So that's in Sumatra in Indonesia, Lake Toba, North Sumatra, volcanic zone. It produced tons, 2,200 to 4,400 tons of H2SO4. This is the one. Yeah, 74,000 years ago. So this is the one that wiped out pretty much all humans except for 3 to 10,000 breeding humans. And this one had an ejecta volume of 2,800 cubic kilometers. So again, very large. But the first two that we discussed had, I think, 5,000. There's Lake Toba.
It's putting it in the perspective there. It's insane.
Yeah. Orua Nui eruption, North Island, New Zealand, Taupo volcanic zone, Taupo volcano. So this one was 26,500 years ago with an ejecta volume of 11,070 cubic kilometers. There's a picture of Lake Taupo. Here's another overhead view of just that whole area.
New Zealand is the bomb. We know that from the Lord of the Rings.
Yeah, New Zealand. Actually, if I had to say one other spot was similar to Yellowstone, out of all these, it's the New Zealand one. It seems to be, or maybe Sumatra, like where Lake Toba is. Those three areas are pretty active with all this, these crazy eruptions, and obviously that Lake Taupo one has produced more than a few. Again, here's everything that's going on in South America along its west coast. And then these are just some smaller volcanoes that you will find in Colombia, and I think I've got one with Ecuador there for my man Maurice.
Yes.
So when you visit, you can go. We can send you to one of these volcanoes.
Well, the one, what the hell is the name of it? No, maybe it's not a volcano. It's a massive mountain.
Yeah. And then that's how it could end up.
Hey.
But yeah, so that's pretty much the presentation. I mean, we might do a part 3 at some point. I don't see a point. Currently, there's nothing big that's really happened. I just wanted to go through some of the other actual super volcanoes other than the Yellowstone and the Lake Toba one. And I thought it was good to go over. Like I said, I keep seeing these reaction videos and these
So quiet down, folks.
These people
Just
trying
relax.
to scare people or people that are freaked out.
Well, that's what it's all about, man. It's getting the scares, getting the views.
Yeah, we're not trying to do that. I just want to put credible information out there. Obviously, a lot of the stuff is taken from the USGS and Wikipedia and all that stuff, so it's all legit. And if anybody has, for an idea for like a part 3 or something we didn't get to or talk about, I'm more than willing to take a look at that as well. But I just wanted to do part 2 because we said we were going to do it. And then I'm also we're going to, for the slideshow episodes that we do, I'm going to focus, we're going to go back to ancient Greece and focus on, we haven't gotten yet to the Eleusinian mysteries. And I want to do some Greek mythology. Yeah, I mean, so far I think with ancient Greece, we've covered the pre-Socratic philosophers. We covered Plato, Socrates, Aristotle, and we covered the Sophists, and we did an episode, I think part 4 was on the megalithic structures of ancient Greece. So, yeah, I want to get back to ancient Greece and then work off that. I don't know what we're going to do after ancient Greece. I've been contemplating, should we do Egypt? Should we do, the Sumerians? Should we do Mesopotamia in general? I don't know. We'll kind of look at that from after we finish Greece. But I want to finish this and then go back to ancient Greece, and then we'll work our way through everything again. So
beautiful, my man.
All right. Well, don't forget, everybody, tomorrow we will be live at 11:30 a.m. Eastern Time with psychedelic scientist Matthew Johnson. That's going to be a great show.
Yeah, I'm pumped up.
Yeah, I got a bunch of questions ready to roll. He's also an expert in cognitive behavior and like different, obviously the way we process things in the brain and having OCD. I think we can have a really interesting conversation. So,
yeah, we'll learn some definitely some juicy tidbits there tomorrow, and we'll go from there.
Yep. So head on over to patreon.com/MindEscapePodcast. Again, we're on Discord. Come chat on there if you want to see when upcoming episodes or who are the guests are going to be. We also have Avi Loeb, who's a scientist, coming on, who you might know his articles surrounding the Muamua object that came through our solar system last year. We'll be talking about that, extraterrestrial life, and all that kind of stuff. So,
yeah, that's going to be a real good one.
Yeah.
I'm watching talk about that thing on Joe Rogan a little bit, actually. That's a very interesting subject.
Yeah, he was recently on Rogan. He was also on Lex Friedman's podcast, and Matthew Johnson was somewhat recently on Lex Friedman's podcast. So, I like what Lex Friedman's doing with the podcast. The scientists, the cognitive stuff, it's either an AI scientist or philosophers. He's had some UFO people. He had David Fravor on. I like what's going on there. So
Absolutely.
But yeah, so go to Patreon, and for $2 a month, you'll get some exclusive content. We'll probably do a segment with Matthew Johnson, and I think we'll probably do one with Avi Loeb too. So if you're interested in those, $2 a month will get you in the door. And then we're going to work on doing another secret episode. So if you don't know what a secret episode is,
Secrets.
we're going to be doing some different stuff. The first one was kind of interesting, and the second one, I've got some ideas. And eventually, like I said, we'll work our way. We want to do some experiments or some outside the box type stuff. So we're working towards that. And yeah, head on over to Indra's Web at indrasweb.org. It is live. Come chat on there. Again, if you want to be an admin on there or have some sort of role helping out, just let me know. Send me an email. I'm going to start really advertising it. So there will probably be a bunch of people on there. If you're on there now, it's kind of like a nice, quiet, small community, but it will be bigger soon. So, and that's it.
All right, my man. I will see you tomorrow.
Yeah, tomorrow morning. Well, we love everybody. Stay safe out there, and we'll catch you next time. Peace.
Peace.